Hi all. um, Today we are going to look at quartic graphs. The last time we are looking at cubic graphs, how to plot cubic graphs or how to sketch them to be specific. Today we are going to look at quartic graphs. That is graphs that have degree 4. More or less, you're looking for 4 solutions to this type of graphs. If you want to get the full version, the full recording of this session, you can follow me at YouTube at this address at MUNIRRMKTURAY. This is the address on YouTube. You can get the full video. You can listen or watch the whole video. Thank you. So let me just take off this one. Now, when we talk about quartic graphs, we are looking at graphs of this nature. Y equals ax to the power of 4 plus bx to the power of 3 plus cx to the power of 2 plus dx to the power of 1 plus e, where a, b, c, and d are all real numbers, and a cannot be equal to 0. So this is the condition. These are all set of specific. And we're going to look at problems in order for you to be able to understand what all these variables mean. So let's look at a problem and try to solve it, and along the way we shall explain the process involved. Problem number G, y equals x minus 3 to the power of 2. We have this one that says y equals x minus 3 to the power of 2 multiplied by x plus 1 power of 2, x plus 1 to the power of 2. And you are asked to plot or to sketch this graph. So how do you go about it? We know the conditions for sketching a graph. You find the intercepts on the x and y axis, and you also determine the behavior of the graph when the x value approaches minus or plus infinity. With those conditions, you'll be able to solve this complex equation. You'll be able to sketch it. So when you see something like this, they said it's a quartic graph, quartic equation. When you open up this or you expand this parenthesis, you will get your highest value here will be equal to x to the power of 4, because this is 2, this is 2, it means x squared here, multiply x squared times x squared, you get x to the 4. Or what this equation means is x minus 3 multiplied by x minus 3, that's for this one, and multiplied by x plus 1 multiplied by x plus 1 again. So 1, 2, 3, 4, x times x times x times x, you get x to the power of 4. But they have factorized it, makes it simple to solve. So if that is the case, let's look at what we have. To find where the graph touches or crosses the x-axis, it's got to be where y equal to 0. So for the graph crosses or touches x-axis at y equals 0. So this is our first condition. The graph either crosses or touches the x-axis at y equals 0. I'll explain this. Crosses, touches, when we start to sketch the graph. So then let's put y equal to 0 and see what we get. From this equation here, this equation we have y equals x minus 3 to the power of 2, x plus 1 to the power of 2. If we now say y equal to 0, so that we can satisfy this condition, so then this is going to be x minus 3 to the power of 2 and x plus 1 to the power of 2 all equal to 0. So in fact we are saying that x minus 3 to the power of 2 equals 0, or x plus 1 to the power of 2 equals 0. From this condition here, if you have two terms multiply two terms together, when the result is 0, then either one of them is equal to 0 or both of them are equal to 0. So that is just the condition we stated here. So what does this mean? This first one is in fact telling us that x minus 3 and x minus 3 are all equal to 0. So again, this simply means x minus 3 equal to 0 twice, two times. X minus 3, x minus 3, x minus 3 equal to 0 twice. So this means x equals to 3 twice. Likewise, this one is telling us x plus 1 times x plus 1 all equal 0. So that means x plus 1 twice equals 0. It implies x plus 1 equal to 0. This is twice again. Therefore, x equals minus 1 twice. 2 roots. Twice, 2 roots, you get your 4 roots. So which means the graph crosses or touches x-axis at 0, 1 twice and 0, minus 1, sorry, minus 1 twice and 0, 3 twice. Yeah, both are twice, 2 times. I want to erase this side. Yeah, so we've done this one for the x-axis. So where does it cross the y-axis? It crosses the y-axis. Now, second condition, graph crosses y-axis at x equals 0. When x is 0, that is the position at which the graph cuts or crosses the y-axis. So if we now have here y equals x minus 3 to the power of 2, x plus 1 to the power of 2, and then we want to put x equals 0 so that we can find a value for y. So if x is equal to 0, then we'll have here 0 minus 3 multiplied by 0 plus 1. This is squared, sorry. So you will have here minus 3 to the power of 2, 1 to the power of 2. So minus 3 times minus 3 is 9. 1 times 1 is 1. So it's 9. So it crosses the y-axis at value 9. Yeah? So, yeah, I leave that one. So now, you look at the equation again. That's the last bit. After that, you just start to sketch your graph straight away. Once you are able to find where it touches or crosses the x-axis and where it crosses the y-axis, your next stage now is to observe this function, the behavior of this function when it approaches minus infinity and plus infinity. So now, when x approaches plus infinity, what is the behavior of this function? If x takes higher values, if x is big here, like 1,000 units, you multiply them together. So what will be the value of y? You have like 100 minus 3, which is 97. 100 plus 1, 101. When you multiply, you get big value of y. So it's telling us when x approaches plus infinity, y also approaches plus infinity. X goes plus, y goes plus. The higher the value of y, the higher the value of x. For plus infinity. Now when x approaches minus infinity, what happens to y? If x goes smaller, take negative values. It takes negative value. What will happen to the value of y? Because this is squared, this one too is squared. So no matter what value, negative value x takes, it is always going to be positive here when you multiply them together. Because this is squared, negative times negative you get plus. If this is also negative here, but you multiply negative by negative, your final answer will be plus. So you're going to get plus plus. So no matter what the negative value of x is, your y value is always going to be positive. So therefore, when x approaches minus infinity, y will approach plus infinity. So once you figure this out, then it's easy now to sketch the graph. Now let's start the process of sketching our graph. This is our y-axis and this is our x-axis. And we know we have minus 1 twice, 3 twice. So if I put here 1, 2, 3, 1, 2, 3, 1, 2, 3, minus 1, minus 2, minus 3. Of course, here is 0, don't forget. And I put here 2, 4, 6, 8, 10. Minus 2, we don't have negative y, so we just ignore on the negative side. So you have 2, 4, 6, 8, 10. So we have minus 1 twice. It crosses the x-axis at 0, minus 1 twice. So 0, minus 1 twice is here. So what does that mean when you have this value here appearing here twice? It means the graph doesn't cross the x-axis. It just touches it. That's the meaning. When you have two roots at the same point, it means this graph just touches the x-axis. It doesn't cross it over it. It doesn't go through it. It just touches it, or it bounces. It just bounces and goes back up from wherever it is coming from. And again, the same thing applies here. You have 0, 3 twice. Again, the same thing. It bounces. It just touches. It doesn't cross. Yeah? So that's for the x. On the y-axis, we know it crosses the y-axis at the point 9. So this is 8, 10. So 9 is just in the middle here. So now we have these 3 points. We have one here, another one here, and another one here. We now need to join all these points together. Then we come to look at the last condition, at the behavior of the graph from one extreme to the other extreme, from minus infinity to plus infinity. So we stated that when x goes to plus infinity, y goes to plus infinity. So when the value of x increases, we now know we've got to join this, because we've got to join this. These are smooth curves, not straight lines. And also here, sorry if my lines are not smooth, I need to make them smooth. First, we've got to join this. Yeah? And then we'll come to this infinity thing. We are told when x goes to plus infinity, y goes to plus infinity. That means this condition satisfies this side here. If x goes further right, y will go right up. Yeah? So it means that's why it bounces. It doesn't go through, it doesn't cross. Here we know now that it goes like this. Let me put 3 here. That is the condition there. And what about here? Here it says when x approaches minus infinity, y goes plus infinity. So y goes up. It doesn't go down. While x is going towards the left at very high values, yeah, y is going up. It keeps increasing. So again here, it bounces like this. Let me put my minus 1 here. It bounces like this. So this is the nature of the graph. It's like a W. This is the nature of the graph. So we finish with quartic equations, plotting them or sketching them, because it's the same principle with cubic graphs, how to sketch cubic graphs and how to sketch quartic graphs. Is the same principle. So this is the only problem we'll solve. Then we shall move to another topic. Thank you for watching. Bye bye.